Let's talk about quadratic solving with radicals. So in here, we solve equations with radicals and check for extraneous solutions. We'll look at equations that have roots in the problem. As you might expect, to clear a root, we can raise both sides to an exponent. So to clear a square root, we can raise both sides to the second power. To clear a cube root, we can raise both sides to a third power. There is one catch to solving a problem with roots in it. Sometimes we end up with solutions that do not actually work in the equation. So this will only happen if the index on the root is even, and it will not happen all the time. So for these problems, it will be required that we check our answer in the original problem. So if a value does not work, then it is called an extraneous solution and not included in the final solution. So when we say extraneous, that means the solution, extraneous solution is a solution that emerges from the process of solving the problem, but it is not a valid solution. Okay. So when the index is even, then we need to check our answer. If both sides are equal, then that means that is a true solution that we got. If both sides aren't equal, then that is an extraneous solution, an invalid solution. So let's try solving some examples here. Let's say we're given square root of 7x plus 2 equals 4. So we have here an even index. We'll just have to check our answer or our answers later. So since we have an even index here of 2 square roots, so we just have to square both sides and then simplify the exponents. So let's square both sides. Or we can just, so you won't be confused, we can square them one by one. Okay, so the square of 7x plus 2 is just equal to 7x plus 2, and 4 squared is just 16. And then we solve for x here. We subtract 2 from both sides. This cancels out, so we're left with 7x. 16 minus 2 is 14, and then we divide by 7 both sides, and this cancels out, so x is equal to 2. Since our index is even, then we need to check the answer in the original problem. So all we have to do is we substitute the value of x to the original equation. So our original equation is 7x plus 2 equals 4. Then we plug in 2 here for our x, so that would become 7 times 2 plus 2 equals 4. So this would be square root of 14 plus 2 equals 4. Square root of 16 equals 4, and square root of 16 is just equal to 4. So that means our solution works, and this is a true solution. X is a true solution, so x equals 2. That is our final solution for the problem. So let's try another problem. Okay, what if we're given cube root of x minus 1 equals negative 4? So we have an odd index here, so we don't need to check our answer. So all we have to do is we cube both sides. So that is cube root of x minus 1 raised to the power of 3 equals negative 4 cubed. So cube root of x minus 1 raised to the power of 3 is just equal to x minus 1, and then negative 4 cubed is just equal to negative 64. And then we solve for x. We add 1 to both sides. This cancels out. Then x is equal to negative 63. So this is our solution. Okay, what if we're given this problem? Okay, fourth root of 3x plus 6 equals -3. So our index here is even. That means we will have to check our answers later. So we just have to raise both sides to the power of 4. That will be fourth root of 3x plus 6 to the power of 4 equals -3 to the power of 4. So this is just equal to 3x plus 6. And -3 raised to the power of 4 is just equal to +81. And then we solve for our x here. We subtract 6 from both sides. This cancels out, and then we're left with 3x equals 75. And then divide both sides by 3. Our x is equal to 25. So we need to solve for, check our answer here. So let's check if 25 is a true solution to our problem. So let's just plug in 25 to the original equation. Fourth root of 3x plus 6 equals -3. So this is the fourth root of 3 times 25 plus 6 equals 3, -3. So 3 times 25, so that is 75. Plus 6 equals -3. Fourth root of 81 equals -3. So 81 can be written as 3 to the power of 4. So the fourth root of that is just equal to 3. Okay, so 3 is not equal to -3. Therefore, x equals 25 is not a solution to this problem, and this is an extraneous solution. So if the radical is not alone on one side of the equation, we will have to solve for the radical before we raise it to an exponent. Say for example, we're given this problem here, x plus square root of 4x plus 1 equals 5. Then we have an even index here, and our radical here is not alone on one side. It has x, another variable x. So we have to solve this first before we raise the radical to an exponent, or both sides to an exponent. So we can subtract x from both sides. This cancels out, so we are left with square root of 4x plus 1 equals 5 minus x. And now we can square both sides. So this is just 4x plus 1 equals 5 minus x squared. This one can be written as 5 minus x times 5 minus x, and then you can do FOIL if you don't memorize the special products. So this one, the 5 minus x squared, is just equal to 25 minus 10x plus x squared. And then we reorder terms here, and then we make the equation equal to 0. Okay, so, or we move everything to the left or to the right. We can move 4x plus 1 to the left and then equate this to 0. So this would become 25 minus 10x plus x squared. Since 4x here is positive, so it will become negative 4x minus 1. And then we group like terms. We start from the highest degree, highest exponent, which is x squared. And negative 10x goes with negative 4x. So that is negative 14x. 25 minus 1 is just 24. And now we can factor this. Okay. I hope you know how to factor quadratics. you can check from the other video. So the factors of this quadratic equation is just x minus 12, x minus 2. Okay, you can either use you can use AC method for this. Okay, therefore the values for our, we have two values for our x. So x minus 12 equals 0, so x is equal to 12, or x minus 2 equals 0, x equals 2. So we need to check our answers in the original problem because a radical is even. So let's try checking x equals 12 first. So okay, so let's plug in x equals 12, 12 to x in the original equation. So our original equation is x plus the square root of 4x plus 1 equals 5. Then we plug in 12 here. 12 plus square root of 4 times 12 plus 1 equals 5. So we have 4 times 12 is 48, plus 1 is 49, so that is square root of 49 equals 5. So this is just 12 plus 7 equals 5. And this is just 19, which is not equal to 5. Therefore, x equals 12 is not a solution, it is extraneous. Okay, let's try checking x equals 2. So let's plug in 2 to the equation. That would be 2 plus square root of 4 times 2 plus 1 equals 5. So that is 4 times 2, 8 plus 1 is 9 equals 5. So this is 2 plus 3 equals 5. Therefore, that is just equal to 5. Therefore, x equals 2 is our solution because it works. So this example here illustrates that as we solve, we could end up with an x squared term or a quadratic. So in this case we remember to set the equation to 0 and solve by factoring. So we will have to check both solutions if the index in the problem is even. And sometimes both values work, sometimes only one works, and sometimes neither works. So, okay, if there is more than one square root in a problem, we will clear the roots one at a time. So this means we must first isolate one of them before we square both sides. Say, for example, we're given square root of 3x minus 8 minus square root of x equals 0. We have here an even index, so that means we will have to check our answers later. So we first isolate the first root. We can add square root of x to both sides, or move negative square root of x to the right. So let's just add square root of x to both sides. So this cancels out. So we are left with square root of 3x plus 8 equals square root of x. Then we can square both sides. So this is just, okay, this is minus 8. So 3x minus 8 equals x. And then we solve for x. Okay, we subtract, let's say we subtract 3x from both sides. So this is negative 8, negative 2x divided by negative 2. So our x is just equal to 4. So we need to check our answer because our index is even. So we plug in x equals 4 to the original equation. So that is 3 times 4 minus 8 minus square root of 4 equals 0. So 12 minus 8 is just 4. So this is square root of 4 minus square root of 4 equals 0. So this is 2 minus 2 equals 0, 0 equals 0. So that means x equals 4 is a true solution to our problem. So when there is more than one square root in the problem, after isolating one root and squaring both sides, we may still have a root remaining in the problem. So in this case, we will again isolate the term with the second root and square both sides. So when isolating, we will isolate the term with the square root. So this means the square root can be multiplied by a number after isolating. Say, for example, we're given this problem. Square root of 2x plus 1 minus square root of x equals 1. So we have an even index here. That means we will have to check our answers later. We isolate the first root. Okay, we can add square root of x to both sides here. This cancels out, so we are left with square root of 2x plus 1 equals 1 plus square root of x. And now we can square both sides, or we can write this as square root of x plus 1. Okay, then we square both sides, and this is just equal to 2x plus 1 equals, okay, we recall from the special products, the square of the sum. So square root of x plus 1 squared is just x plus 2 square root of x plus 1. And then we group like terms, or we can move everything to the left or the right, either way. Okay, so that is 2x plus 1 minus x minus 2 square root of x minus 1 equals 0. So this one goes with this. That is x. 1 minus 1 is 0, minus 2 square root of x equals 0. And now we can move negative 2 square root of x to the right. So this would become x equals 2 square root of x. Then we can square both sides. Square both sides. So we have x squared equals 4x. Then we combine them. X squared minus 4x equals 0. So we can factor out x here. So our x is equal to 0, or x equals 4. So now we need to check our answers because our index is even. So we just have to plug in x equals 0 or x equals 4 to the original equation. So that would be square root of 2 times 0 plus 1 minus square root of 0 equals 1. So this is square root of 1 minus square root of 0 equals 1. 1 minus 0 equals 1. 1 equals 1. Okay, so that means x equals 0 is a true solution. How about when x is equal to 4? So that would be square root of 2 times 4 plus 1 minus square root of 4 equals 1. So that is 2 times 4, 8, plus 1, that is square root of 9, minus square root of 4 is just 2, equals 1. So 3 minus 2 equals 1. So 1 equals 1. That means x equals 4 is also a true solution to the problem.